Yeah. Okay. Can you see my screen?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay. So good evening, everyone, and welcome to this live session for the labs for the electronics lab that we are going to do this term. Right. So the idea is the objective is to build elementary digital circuits to meet certain functionality. You should be able to measure voltage and current characteristics of elementary electronic devices like diodes and transistors. Right. So we are trying something innovative here. Let me come to that later. But for now, let me start with some very basic questions. Have all of you received your kits, your component kit?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so in that, do you see this IC 7400?
Yes.
Right.
Yes,
Okay.
sir.
So the first experiment that you have to do is actually something I had already done in the digital systems course. You remember in the first week, I demonstrated the voltage transfer characteristics of a NAND gate. Do you
Yes,
remember?
sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, so you need to now do that experiment first. Okay. So in order to do that, you need to wire up the circuit. You need to do a lot of things with the breadboard. You need to understand how to read the IC. All these things are there, right? So what I am going to do is, what the way we are going to go about this is, I will be giving you demonstration videos. Okay, like it's a do-it-yourself video. Okay, you look at the video and do it step by step, like how you did in the electronic system thinking lab, right? I gave you a demo video and I asked you to follow the same steps. Similarly, I will be asking you to do something very, very, very similar here. Okay. So have you people received the video link for the first experiment?
Yes,
Yes, sir.
sir.
In our
Yes, sir.
dashboard only.
Yes, sir.
Right. Okay. So basically the idea is there are two parts to this. Okay. One is the process of assembling the components on the breadboard. Okay. So for that you need to you need to understand the pin configuration of that IC. You need to know which pin to connect where, all that, right? So that information I am providing via the video, and that is what has been given to you. Okay. Now, I don't know, can one of you share that video link with me? Because I don't know where it has been uploaded. Can you just share that video link with me on the chat?
Sir, I have shared it.
Okay, excellent. So let me just check that.
Welcome, my
This one is
fellow developers. Software development is incomplete without SOL app.
okay. So let's see. So now
Means one,
two, and are you able to see my screen by the way now with the video?
Yes, sir.
Yes, sir.
So if you notice how this video has been made, right? It's essentially, going to list out, exactly how to, for example, here, right? How do you plug in the IC? Okay, where should you plug in the IC? Okay, always you should make sure you plug in the IC in that center part of the breadboard. Okay, otherwise you'll have a short, right? So even such minor details I am telling you in this video, right? How to read the pin configuration of this, right? You have a notch. You have to read the pin configuration accordingly, anti-clockwise and all that, right? Every single minor detail I have provided in the video. Okay. Now For example, look at this thing, right? Are you able to see the screen here?
Yes, sir.
Yes, sir.
I even tell you how to cut the wire so that you make such a small wire connection. You remember in the electronic systems thinking lab, you just put those big wires, right? You didn't really have to cut them and all that. But you cannot do that, going forward, because you'll have many ICs, many such components sitting on the breadboard. So therefore, your wire cutting ability also has to be very precise. Okay, so for that reason, I'm telling you, okay, how to make a measurement, how to cut it, right? The first experiment, therefore, has very, very, very detailed instructions. Okay, like you have to choose red color for power, black color for ground, right? And all that stuff you have to follow. Then, in order to make, let me just show you. I also tell you how to make a probe wire at some point, right? One second. Yeah. So in this part of the video, we tell you how to make one. Strip the wire off and make sure you strip it significantly this time so that you can align the wire along the metal and so if you notice here, right, I am telling you how to make a probe wire connection. Okay, because that wire you will have to plug into the breadboard in order to make a measurement with your multimeter. Right, so I am telling you how to cut the wire so that you can make that probe wire measurement and all those details. Okay, and please, so my request to you is, please watch this video very carefully. Right, going forward, the spoon feeding that I do will be lesser and lesser. Okay, I will just tell you, okay, connect this IC to pin number so and so. You should know how to read, where the pin is, what pin number is, and all that by looking at the data sheet. I'll provide you all that information. But the spoon feeding will come down progressively as you go into the experiments of this course. And that's why please make sure you see the first video in great detail. Follow the instructions exactly as I have given. Okay, in the end of this video, I would have shown you how the circuit must look. Okay, essentially make sure that you follow these instructions, build the circuit exactly, and then go ahead and do the experiment accordingly. Okay, so like I told you, this video that I just clicked on is only how to assemble the circuit. Now, how do you conduct the experiment? For that, please look at the video that I showed in the class, in the theory video. You remember in week 1, I showed you that video, right? How to get the voltage transfer characteristic.
Yes, sir.
So I have done that using the analog discovery kit. You have to do it using your ADALM 1000 kit. Connect the 5-volt supply to the potentiometer to this red color part here, and ground to the black color part here, and then vary the potentiometer using a screwdriver and measure the output voltage using the ADALM 1000 kit. Okay, that is very similar to what you did in your electronic systems and systems thinking lab. Okay, so that's about what it is. I think the procedure, let me just see if they have put something here. No, they have not put anything here. Okay, so now I will open up for questions. Any questions?
Sir, like I want to just know that what is the importance of that capacitor in the circuit?
What is the importance of that capacitor? Right? Okay, the importance of the capacitor actually is not very significant now. The idea was sometimes you might have noisy signals, and therefore you might have to, just kill the noise using a low pass filter. Okay, but here even if the capacitor is not there, it's okay.
Okay, sir. Like so we can use any value capacitor.
Yeah, I have given you some 1 nanofarad capacitor or something. You can put it. Yes.
Sir, is it a bypass capacitor used to bypass the AC voltage?
It's used to sort of yeah, the high frequency noise should be, should just get killed.
So regarding the data that we should show in the experiment video to record.
Yes. Okay, that's a good question. So what I want you to do is the following, right? I want you to make a video of, first of all, someone has to shoot a video of you running the experiment, right? Like for example, you are going to tune let's say the potentiometer here, right? And while you're tuning, you can give some commentary saying what you're doing and how you're doing and all that stuff. Okay, don't just try to record in a reasonably silent place. It need not be like perfectly silent and all that. I'm not asking you to do any dubbing. Okay, though in this video, I have done everything with dubbing because it's meant to be more professional that way, right? But in your case, you can just give a commentary of what you're doing with it. Okay, and while you are doing that, I want you to do a screen capture of the software also, right? So essentially, the way I want you to do it is I want you to shoot it like how I recorded that video in the theory class. You understand? One camera is somebody is recording what you're doing. Then there is another screen capture which is recording what is being captured on the screen. Then you have to mix these two together. Okay, whether you do split screen or whether you do it one after the other, I'm not worried. But you have to do the video editing and put them together.
Yes, sir. So my question actually was, thank you for the information regarding how to record it. But
Yeah.
my question was the data that we have to collect and like the structure that the video should be in. Like first we have to demonstrate making the circuit, then we have to demonstrate the voltage characteristics, taking it like that. So like where can we find the details of that? We do not have any document that details.
Yes. I mean, that's the reason we have this meeting, because I want to first tell you all this and then we'll put all this in a document. Okay. And we will share it with you. Right?
Yes, sir.
So what you basically need to do is you don't need to submit a PDF or something of the measurements that you make. We need one video, that's all. Okay. For example, if you are, you do, let's say you're doing this experiment, voltage transfer characteristic, right? Wait, let me just try to get you that video directly. Can one of you just please post the link to the video of my theory lecture where I do that, this thing? The theory
So for
lecture.
the video recording part, can we use a tripod to record our face and another
Yeah,
camera
yeah.
angle to record what we're doing?
I say one camera is enough to record your face and what you're doing. And this thing, you don't need two cameras there. That's what I'm saying. Okay.
Okay, sir. Yes, sir. I understood. Thank you so
Right.
much.
See, essentially, it's something like this, right? Here, of course, I have a camera on top. In your case, it can be a tripod where part of you and the instruments are also seen. That's all. So I want a video like this, exactly like this. Okay, not all this theory.
Yes, sir.
But I want a video like this from starting from here. This is the measurement you're making. This is what you're doing, right? And then the screen capture is also there. You understand? So you can make it split screen like this if you want. You understand?
Yes, sir. I understood.
Right? And then you even all these readings, right? You can do it on Excel. Right? You do it on Excel and screen capture it and show me. That's all. You plot it also on the same screen and show me. You just screen capture the whole thing and show me. That's all I'm saying. Okay. So basically,
Yes,
every
sir.
video has three parts. One is the experimental setup and you doing something with the experiment, right? Either tuning the potentiometer or changing the input, something, right? Second is the screen capture of the ADALM 1000 kit. you know, the oscilloscope or the signal that you have captured, something like that, right? You're going to show these two things, right? For in the future experiment, for example, you will give input through one, right? One signal you will give, square wave you may give, and you may capture another square wave back. Okay, so you will show this screen, you know, saying this is what it is, right? And the third one is, you know, final set of tabulated readings that you have taken. You follow?
Yes, sir.
Yes, sir.
Yes, sir.
These three parts have to be done. You have to, you know, first capture them independently with a camera, with a screen grab, whatever, and then edit them.
What is the deadline for this one first experiment?
Sorry?
What is the deadline given to us for this first experiment to submit the?
So you have 8 experiments and you have 2 months. Okay, the month of March and April, right? And May is a buffer time, because when you come here, you will come in the end of May for your evaluation. Okay, so May is a buffer time. So typically we would say try to finish one experiment in a week, and the deadline will sort of be weekly, where you're supposed to upload your videos. Okay?
Yeah.
Yeah. So more details will follow on this, right? But I'm just explaining the basic structure of the lab.
Sir, would you also be required multimeter for that also, no? For recording video and for our setup.
Yeah. You would require a multimeter. You have to purchase one. We are not particular about which brand, what to buy and all, because first, some of you may already have a multimeter, in which case, please use it, right? Some multimeters are available in various ranges, right?
Yes, sir.
We don't need something really sophisticated, right? We basically need something. That's why please watch my video first, right?
Okay.
My first video that I'm showing, no, you watch it. You will know what all functionality of the multimeter you need. Okay,
sir.
it has to be voltmeter. You should be able to do connectivity check. Okay, that means if you touch the two probes to each
Then it
other,
will show the reading.
it must beep.
Yes, beep.
Yeah. So the connectivity check you must be able to do, right? So we may not even measure currents. We may only measure voltages, but it's good to have a current this thing also. There's no problem in that. Any multimeter will come with that in any case. Okay.
So
Okay,
in this,
sir.
I'd like to ask, I have a very old school multimeter that my grandfather used. In that, there's no function for measuring capacitance. So would that cause any issue?
I don't think capacitance we will be measuring.
Okay, sir. Thank you.
So I leave it to you. If you think you can manage, that's why I'm saying, see my video. Okay. You will understand what all you need from that.
Yes, sir.
And if you can manage, please manage. No issue.
Excuse me, sir. I have made a 10-second temporary clip for our lab videos, and I would just like to show it to you, asking your inputs on it. It's definitely not permanent because I haven't added my face and all. So can I just show it to you? It's just a 10-second clip. So I would like your inputs on that.
I will stop sharing. You please share your video.
Yes, I'm sharing my screen. Yeah, I hope it's visible.
Yeah, it is. Yeah. Okay. So the first thing is, I think the video part is okay. The audio is not.
Yes, sir.
I don't want music. I want to hear your commentary about the experiment while you do it.
Right, sir.
Tell us what you understand. Tell me what you are doing. Tell me why you are changing the potentiometer there. Right? Tell me that. right? Tell me what you should expect on the multimeter. Give a running commentary of what you're doing with the experiment,
Right.
right? And the video
So it,
must
yeah.
and I don't want sophisticated editing. I'm saying I'm not here to test your editing skills. I want you to capture it clearly so that we can see what is going on. I want to make sure you are doing it correctly. That's what we want for evaluation. Okay. So I think it's
Yes, sir.
a good start that you have given me, but just focus, make sure that the audio is, it, like I said, I don't care if you are doing it in a slightly, if it's not perfectly silent. I want to hear your commentary.
Yes, sir.
Yeah,
So it's
the
basically
commentary.
an explanation of
Yeah,
an explanation of what I'm doing while performing the experiment while the video is going on.
यस कमेंट्री आप हिंदी में भी कर सकते हैं लेकिन अंग्रेजी में ट्राई कीजिए प्लीज ओके
Yes, sir, definitely.
ओके या
Yeah, thank you so much, sir.
या
Thank you, sir.
यस प्लीज टेल मी
Sir, like I have a question regarding the IC 7400.
या
Sir, like this is basically the NAND gate, but one of input is put too high, hence this is acting as an inverter.
करेक्ट
So, sir, like I have performed this experiment previously with the transistor C547,
ओके
not this IC. So, sir, like can I build a NOT gate without this IC, like with the transistor, etc.?
so internally this logic gate is built using transistors only. Okay.
And
So,
sir, like
yeah.
sir, yes. Sir, like without transistor using basically with the wires and this OR and OR gate, how can we build without just basic stuff?
No, I didn't understand. Like what?
Sir, like the AND gate and OR gate and not gate basically are if I give two inputs, then output should be two inputs high, then output should be high, and if I give one of the input low, then output should be low in the
Yeah.
case of AND gate.
Yeah.
So can this happen with transistor also?
It does happen with transistors only internally. Inside.
But sir, without a transistor.
Sir, I believe
Yeah.
I may just try to interpret his question. I believe he's asking if we can create the circuits using transistors that are internally there in ICs.
No, you can. You can definitely do it.
Sir, I would like to add one thing.
Yeah.
Yeah, what I have observed when doing the same experiment with transistors is like the VIL and VOL will be different. I mean, the levels will be abnormal.
No. So first of all, when you do with transistors, it also depends on how you put the transistors together. Okay, I can build an inverter with an NPN transistor and simply a resistor.
Okay.
Yes, sir.
Okay, so I don't know if you can see can you see the board behind here?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Oh, 1 second.
Yes, sir.
Let me just check if I have chalk. Just 1 second. Uh, Sorry, I don't know. Okay, I don't know where the chalks went. So wait, let me just try.
Also, sir, I just had a technical
Yeah,
query. In most of our experiments, I noticed that we are using the 7400 gate for a NAND. So, I mean, where sort of NOT gates are used. So, is there any specific reason we are using the 7400 gate where the 7404 basic inverter can also be used?
no, nothing. I don't think historically. Let me see this. Having another input, I think, was useful. Historically, it's the same thing actually. Look, I think it might have come from, earlier, the NAND gate can be used as an inverter. Okay. And 7404 might not have been shipped to people.
Yes, sir. We have not received the 7404.
That's all. Because I think that IC apparently is not available right now. It will come to you in some time. That's the reason we are doing this. That's all.
Right.
Okay. So just give me 1 second. I'll show you this. Okay. Yeah. Are you able to see my screen?
Yes, sir.
So you see this picture here, no?
Yes, sir.
There is that bottom thing. You just treat it like an NPN transistor. Okay.
Yes, sir.
The output
sir.
is taken out at the resistor, right? This is also an inverter only.
Yeah.
Right? The VOI, VIL, VIH and all, it depends on what the structure is internally. What
Yes.
you have inside this IC is something called a totem pole output and all that, some really complex stuff. But therefore, what I'm trying to say is what you built using transistors may not be the same as what is inside the IC. Okay, and if you change the transistor structure and all that stuff, no, the VIL, VIH characteristics will change.
Yes, sir.
Okay. Yeah. That's the point.
And sir,
Okay.
one more thing is there. Like previously, I was asking that basically I have tried to the circuit the AND gate with two switches. If both the switches are on, then only the input will pass. Then only the circuit will work. And if one of the switches is off, then circuit will not work. Circuit will be treated as open circuit.
Yeah.
So this functionality can only be achieved with transistor only, or there is any other electronic element as well.
So see, first of all, the behavior you is actually not an AND gate at all. Because an AND gate for any combination of inputs should either produce logic 1 or logic 0. Open circuit is a different state. Right? If you remember my lectures that I did, I spoke about a tri-state inverter.
Yes, sir.
Open circuit is a different logic state from logic 1 and 0. Okay. So in fact, the reason even in this previous thing that I just shared, right? If you notice the the NPN transistor was pulling to ground. Correct. The
Yes,
resistor
sir.
is pulling up to VDD.
Yes, sir.
Okay. So what is happening is, depending on the input, the output will either be pulled to VDD or it will be pulled to ground.
Yes, sir. Right.
Okay. Whereas if you connect it like in series, no, like that, between input
Yes,
and
sir.
output, then the output will end up being floating. It will be open circuit. And that is not an AND gate at all.
Yes, sir.
Okay. So keep that in mind. So in this course, we are not going into how these circuits are built. That we will do in a later course.
Okay, sir.
Okay.
Sir,
Yeah.
so can we use some 4000 series ICs because I have them laying around here, like a CD 49s
Now what circuit
with
is,
74.
I don't know that.
No, like I have some CD 4000 series ICs. Can I use them with the 7400 ones?
Look,
It's a
so
CMOS one.
yeah, when you are, no, you must be careful about this, because what matters is not just the voltages. Okay, the current driving capability is also important for these ICs. Okay, so therefore, I don't know if these things will work together. So you
Okay,
are
sir.
free to try. You are free to try, but keep in mind that the current driving ability may not be sufficient to drive these gates.
The data sheet say it can drive two TTL or DTL inputs, but
Then it
I'm
should be
not very
okay.
sure.
Then it should be okay.
Okay, sir.
Okay, yeah. Any other question? Okay, so the idea is, because this is the first time we are doing this lab, right? Let us have a live session every week. Okay? Maybe the same time.
Yes, sir.
Okay, Victoria, can you please set that up every week for me? Monday 4 to 5.
Sir, I will do that. Yes, sir, I will do that.
Okay, so I'd like to understand and see their progress every week.
Sir, can we record this session? Because I'm in the office, sometimes it may or may not be possible for me to watch it live.
No, that is sure. So, Victoria, we should record and put it up. Is this
So
not?
it is in YouTube also. You can live streaming it in YouTube also.
Oh, it's live. Okay, it's being live streamed to YouTube and therefore it will get saved automatically.
Yes.
Yeah. So it's already being done. Whoever asked.
Oh, okay, sir. Thank you very much.
Okay. Yeah. Okay, very good.
Yes, sir. I have a request.
Yes.
Yeah, sir, if you just can publish a video of whatever you are saying that every week we have to submit a video of explaining about the experiment. If you just upload give us a sample video of that, it would be very good for us.
So I will try to give you one sample video for one experiment. I can't do this for every experiment.
Yeah. No. I just only want for one.
Yeah. Done. Okay, done.
Okay. Thank you, sir.
Okay, cool. Okay, then I think we'll stop for now.
Sir.
Yeah. Yes.
Sir, where do we have to upload these videos?
We will keep you posted.
Oh, okay, sir.
This video, this interaction was to just get you started, right? To tell you what to do and all that. And by the way, the other thing we are also exploring is we are looking at doing this lab at a basic, intermediate, and advanced level. Okay. Some of you, depending on the time you have and all that, might want to do more than what we usually expect. So therefore, we do have this advanced level also. Okay, some experiments, but everybody has to do the basic experiments. Okay, advanced, intermediate, advanced is optional. If you have time, you want to explore, please do it. Okay, but we will give you at least we'll put out problem statements that cater to the intermediate and advanced level for sure. Okay.
Sir, can you provide us the schematics with the experiment? Like the pinouts and all?
No, that will be there in the video or a document.
Okay, so like a CAD models and all, because it will be easier to follow up.
No. CAD models we don't provide. We will provide the schematic thing. This has to be connected to pin 6, pin 4, that kind of information we'll give you.
Okay, sir. That's it.
Okay, but progressively that will come down. Okay. That spoon feeding will come down. I'm saying slowly. Initially, we'll give you all the details. How to read the pin, how to connect to pin 5, pin 4 and all. Later, I will just say, please connect the output of this counter to this. You should know how to identify which is the output pin of that counter from the data sheet. Okay. So we'll do this. We'll do this over time. We'll sort this out.
Okay? Means, sir, step by step, we will increase our level. Means by seeing the video, by experiencing, or by doing the.
That's the idea. You have to improve your level and eventually be able to read data sheets and understand them yourself.
So, sir, can we also include the schematics that we create on our own in the videos?
No, you can.
Sir.
Yeah.
Okay, sir.
Sir, can I ask a basic digital systems question?
Yeah.
Sir, you have explained the XOR gate with various examples, and you just mentioned that if the number of outputs are odd, then XOR gate will produce a high input, and if it is even, then it will produce a low input.
Yeah.
Right.
Yeah.
Sir, I am reading a book that you prescribed, the Morris Mano book. Sir, in that book, that exclusive NOR gate is the opposite of XOR gate. So basically, XNOR should use the opposite of XOR output. But sir, XNOR is also mentioned as the equivalence gate, right? So if two inputs are equal, then it will produce the high output. And if two inputs are not equal, then it will produce a low output. And the XOR gate, you mentioned that if there is an odd output, then the odd one, then it will produce a high output. So if we just increase the number of inputs, suppose XOR inputs are 3 inputs. So if there are 3 1, then there should be a high output. And but XNOR is the opposite of XOR. So that also will produce a 1 because that is an equivalence function according to the book.
No. See, again, this equivalence function and all, you should be careful, right? Equivalence, I can talk when I have 2 inputs. When I have 3 inputs, what is the meaning of equivalence? So if I have A, B, C,
okay,
is A equal to B equivalence, or B equal to C equivalence, or A equal to C equivalence?
okay. So
Yeah,
only two in case of 2 inputs, it will be called as
exactly.
an equivalence function.
Exactly. Yeah.
And rest it will be working opposite of XOR only. That is always true.
Yeah. Just treat it as XOR just indicates odd number of ones.
Okay.
That's all. XNOR will just invert that for you. That's it.
Okay, sir. Thank you, sir.
Okay.
Sir,
Right.
so
Sir,
XNOR will
also
indicate even
regarding
numbers of.
this subject as a separate, we have this electronics lab as EE1103L. So
Yeah.
it would be nice if we could have a separate forum for this on Discord so that we can discuss lab related doubts. And
Yeah.
I mean, it would be good if it doesn't intersect with the theory courses.
Correct. So Victoria, can you take care of that?
Yes, sir.
Okay. Yeah. Good. Yes. So even this TA and all that stuff, we will keep you posted. Okay. All this will get sorted out in the coming week. Please get started with your experiment. I want to make sure you're making progress on this, and then things get easier as we go ahead. Okay.
Yes, sir. Thank you, sir.
Okay. So then, thank you all. I'll see you next week.
Hello, sir.
Yeah.
Hello, sir.
Yeah.
I have one doubt in a fundamental question, sir.
Yeah.
Is it correct to say XNOR is a complement for XOR in every input cases?
I don't know. I have not thought about this so much. I just treat XOR, like I said, XOR is just indicating odd number of ones because that is the most
So can you say?
functionality that can be given.
Yes, sir. So can XNOR gate can be said as a even detector?
No. You should be careful because that depends on how many inputs are there in total and all that.
Oh, okay, sir.
Okay,
Yeah,
because see, this is very tricky. That's what I'm saying. That's why I'm saying don't look at any other definition. XOR is basically indicator of odd number of ones.
yes, sir.
Even the example I gave you, right? That hat example.
Yes, sir.
It is useful to just indicate odd number of ones. That's all.
Yes, sir. So what about XNOR? Isn't it just a complement of
XNOR is just inverted. You add an inverter to XOR. That's all.
Yes, sir. So if we have the 3 input XNOR gate is just a complement of 3 input XOR gate, right?
Correct.
Yes, sir. So because we had some some confusion in this part in one of the GA questions.
Yes,
That's why
I know. So I think the TA spoke to me about that. I was in the US and I was not able to respond in time. Okay.
Yes, sir.
But don't get confused by these, this. Morris Mano does this sometimes. Okay. He will give you some, that it's, he will tell you a certain term and then it can be very confusing. Okay. So, yeah.
Excuse me, sir. Sir,
Yeah.
therefore, yesterday I took literally 3 hours to derive means that XOR 3 inputs and XNOR 3 inputs. And therefore, I managed to compare both of them, and both of them are inverse.
Yeah, correct.
With the K-map I do, and with the K-map and with the canonical form also I have.
Yeah. Right. Correct. Right. Okay. Sorry, I have to head out now. Okay. So we will
Only one feedback I want to give, sir. Only one feedback I want to give. There are a lot of mistakes in Morris Mano, sir. Spelling mistakes, editing mistakes, so many are there.
I know, man. That's not a book I wrote.
Yeah, okay. I'm just giving you a feedback, sir. That's it.
No.
And so
I know. See, it's not. See, let me put it this way. Okay. Morris Mano, I don't think is a great book to read, but it's a great book in terms of providing you practice problems.
Okay. Harris, I'm looking at, sir.
Yeah. So please use it for practice problems. Okay. That's the main thing. Okay. Other things I will tell you what to do. That's the idea.
Okay. Thank you.
Okay. Chalo.
Sir,
Thank you.
one last
last
thing.
question.
Sir, one last thing.
Yes.
Sir, since it's an introductory lecture, the class we are doing, I want to ask what the scope of this electronics lab sessions means. The 8 sessions would be there. 4 for the digital system is given and 4 for the analog. And how it would be in our campus. Mean campus it would be of 1 day, 4 day means it is not being cleared
Yeah,
from this.
it will be 1 day. In the next session on Monday, I will clarify that to you in greater detail. Okay.
Oh, okay, sir. Okay.
All the experiments, how we are going to evaluate, what you are supposed to do, all that we will tell you in the next class. Okay.
Okay. Till then we have time to means.
Yeah. See, you have enough time for everything. So you just proceed with the experiment now. That's all I'm telling you.
Okay.
Okay. That's all. You will even the details of all the 8 experiments will be uploaded by Wednesday. Okay.
Oh, okay.
Chalo. Okay.
Thank you.
Right. Thank you. Yeah. Bye.
Thank you, sir.
Can I ask one last question?
Thank you, sir.
Yeah, Aditya, you can ask it next time. Professor is.
Okay.
So can we leave?
Yes, you can.
Oh, okay. Thank you.
Miss Victoria, just kindly upload this recording.
It is already there. It is live stream in YouTube only. You can check it in YouTube.
Okay, send us the link so that I can have a look because I joined late.
Yeah, link is already shared with you guys in WhatsApp and as well as through email. You can check it.
Okay.